since the next section is optional, I'm going to go ahead. We're talking about factoring and polynomials, and to help us factor, right now we're talking about dividing polynomials. And this still seems to be section 5-4 of the book. And last time we kind of wound up, we were doing long division type dividing. So let's see what I want to do here. So, for example, if I had 2x squared plus 3x plus 4 divided by x plus 2, with the hope that, hope I'll divide without a remainder. I may get a remainder. But in any event, the process is like long division with numbers. Write the divisor here, and what we're going to divide into here. And what do? We look x into 2x squared. Well, that's 2x, because 2x times x is x, 2x squared. Multiply, just like we would with long division. 2 times 2x is 4x. We subtract, so we get negative 1x or negative x. Bring down the 4. And then here, to get negative x, we're just going to have minus 1. So this is going to be x plus 2, negative x minus 2, negative x minus negative x is 0, 4 minus 2 is what? 6. So that's the long division. Gosh, that doesn't feel right. Okay. All right, so there's another method we can use called synthetic division. It's more limited, but it's easier. And I'm going to show you the process. I think the book discusses it in more detail. But it only works if you're just dealing with an x plus or minus some number. Now, if x plus 2 could divide into this evenly, then x plus 2 equals 0, or x equals minus 2 would be a root. That is, we could plug minus 2 into here and get 0, right? This is a factor, and you plug in negative 2, it's 0, and everything's 0. So what you're interested in here is the root. And instead of the x plus 2, we write the root, which is minus 2. And then we look at the coefficients here, all of them. So the coefficient of x squared is 2, the coefficient of 3x is 3, and the coefficient of 4 is 4. And when you do this, you have to make sure you don't leave any out. If, for example, there was no 3x here, you'd still have to put a 0 here. All right, so how do you do this? First thing you do is you bring down the first number here. You take this number and this number, you multiply them, and you put it here. You now take these two numbers and you add them, and then you repeat. Negative 2 times negative 1 is 2, and I bring this down and I get 6. That's the synthetic division process. If you have a longer polynomial, it still works. You just can only divide by a linear term, just an x. Now, let's look at this and interpret it. This is the remainder. It's the same 6 we have here. This is the coefficients of what we got when we divided. So 2x minus 1. It kind of seems like a magic trick. You do one thing here and another thing here and we get the same result. But in fact, we're kind of doing the same thing. It's a little different. We don't have to deal with all these x's over here. We do have to be careful that, like we don't leave one out. Like if we're dividing and there's no 3x, you still need a 0 there, a placeholder. All right, so that's synthetic. We should write it down. Synthetic division. And as I said, this is optional. I'm not going to give you a problem on an exam that says do this by synthetic division. If you like it, maybe if you know it already, or if you want to learn it, that's fine. The long division method will always work. So you need to know this, especially in case this term here isn't linear. Excuse me. There is one more case I want to cover for synthetic division. If you had this as your problem, x squared plus 6x minus 4 over 2x plus 4, and you wanted to use synthetic division here. You seem to have a problem here, right? See, we can't have a 2x here. But you might still be able to use synthetic division. In this case, this is 2 times 4x squared plus 6x minus 3x minus 2 over 2 times x plus 2. And here I can remove the 2. What do you know? I have the same exact problem I have over here, so I could do it exactly the same way. All right. Why doesn't everybody, using the method you prefer, why don't you try 3x squared minus 5x plus 8 divided by x minus 1. Just take a minute. Give that a try. Does anyone have, anyone divide this out and get a result? Tell just by looking that first term is going to be 3x, right? Can we have the next term? 2? Negative 2? Okay, and did you get a remainder? What was the remainder?
10.
10? Okay. Now, I'm going to show you a trick that we're going to use later to do a check. Since this is x minus 1, I take, like if this were set equal to 0, I take the root, which is 1. I plug it in, right? So 3 times 1 squared minus 5 times 1 plus 8. So that's 3 minus 5 is minus 2 plus 8 is 6. I should have gotten 6. Did I do something wrong? Did my check not work? 3, 8, 11. Yeah, okay. So we're going to have to check this. Yeah. Let's try and do it both ways. So, 3.
I think it's supposed to be positive 2 instead of negative 2. I think that's where I messed up.
This is supposed to be positive 2?
Yeah, I think so.
Okay. And but the remainder is still 6.
Yeah, because then it would be negative, like the way it is at the end, it would be like 2x minus 2, so when it like subtracts from the 8, it would be 6.
Oh, you think it should be 6?
Yeah.
Oh, I see what you're saying. Yeah, that may be. Yeah. I think you got it right now, but just to be sure. All right. Real quickly, someone, what number do I put here? I have x minus 1. I know you know, John, right?
So, positive 1?
Positive 1.
Yeah.
So again, I bring down 3. 3 times 1 is 3, plus negative 5 is negative 2. 1 times negative 2 is negative 2. I bring it down to 6. You were right the first time with that. Just somehow you got the remainder wrong. Did you use long division? All right, well, let's see what that looks like. So it's 3x squared minus 5x plus 8, x minus 1, 3x squared minus 3x. Now, this isn't addressed at you, Danielle. This is addressed to everybody. One of the mistakes where people make a mistake is when you're subtracting and you have a negative. That's a very common, you have to really focus when you're doing this. It's easy, 3x squared minus 3x squared, that's 0, right? Negative 5 minus negative 3. That's plus 3. So negative 5 plus 3 is negative 2. And here we have negative 2, negative 2x. Negative 2 times negative 2 again. Watch out. That's positive 2. You subtract, we get 6. So you can take a look and see where, how you got. Oh, well, maybe you added these.
Yeah. That's
Yeah,
what I did.
okay. All right. I guess it's good. You don't want to confuse the two. With synthetic, we're adding. With the long division, it's just like regular division, we subtract. So just keep those separated in your head. Don't, you know, if you're gonna learn synthetic division, carefully, right? Okay. All right, so one of the reasons we looked at division is when you're trying to factor, if you think you have a factor, you can divide it out and see if you get a remainder. If you don't get a remainder, then it was a factor. I'm going to clean up the board here. So again, I want to go back to something I'm going to repeat from Tuesday. Why is this obsession with factoring polynomials? Well, again, if I have some polynomial, all right, I'll just throw this one up. X cubed minus 2x squared plus x. And I have a polynomial equation where this is equal to 0. I know that if I can find factors, that solutions will be found by setting those factors to 0. Because when you multiply two things together, you get 0. Well, at least one of them has to be 0. If either of them is 0, you have a solution. So in this case, well, first I'll take out an x. And now I'm going to use the first method we talked about yesterday, which is we look for a pattern. I hope at this point everyone can see the pattern here. Right? This is our a squared, a plus b squared equals a squared plus 2ab plus b squared. So here my x is my a and 1 is my b. So this is x squared, this is 1 squared, plus or minus. So what do I get? Someone tell me, what do I get here? I have to kind of apply the pattern.
X minus 1.
Whoever said that? Right on. Yes. Okay, so this tells me that the solutions to my equation are either, well, if x is 0, because that makes this 0, or x equals 1. Again, these are called roots or solutions. Sometimes they're called zeros. Because if I were to graph this, I'm not going to draw an accurate graph, but it's going to go through 1, and actually it's going to, because this is a square, it's just going to touch 0. Although I don't think this is the right graph. Okay, so, all right, that's one way to factor. I'm pausing because I'm trying to think of the right order to do these things in. Yeah, I don't think I'm going to do factoring by grouping first. Okay. I think what we're going to look at next, we're we're really going to look at two different methods that are kind of the same method. We're going to do the hard one first because you can use it for other things, right? It's called gosh, I can't remember the name of it. It's called, I couldn't think of the word completing. Completing the square. Has anyone run into completing the square before? Anybody? Okay. It's kind of a, for algebra, it's kind of an advanced topic. But I'll give you an example here. And I'm going to show you why it's called completing the square. Well, I have a square. It's not really a square. And I have 2x here. I have x here. Oh, you know what? Bad example. I'll have to make something else up. There we go. We'll come back to that. Terrible example. Huh. All right, I'll make up a good example. X squared plus 4x minus 3. All right, it is a square. Okay, so here's my square. I take half of this. 2. I have x squared here. I have x times 2 is 2x. X times 2 is 2x. These are like areas. And this is the part that I'm going to complete with. Now, my pattern here, a squared plus 2ab plus b squared, tells me that this is going to be, anyone know what number is going to go here? That's fine. We'll get to how you figure this out. But I've got minus 3. I don't want minus 3. I want 4. X squared plus 4x plus 4. Well, this is equal to 0. So this is equal to minus 3 equals 4. I just took this equation and I added 4. Yeah, this is tricky. Now this is now my nice square here in my a squared plus b squared, a squared plus 2ab plus b squared, which I know is a plus b squared. And here it's x plus 2 squared. And I say, okay, so that's x plus 2 squared equals minus 3 equals 4. Minus 3 equals 4. I add 3 to both sides. 7. And from here, I kind of keep doing the algebra. I find the square root of both sides. The square root of x plus 2 squared is x plus 2. The square root of 7, the square root of 7. But when I take the square root, it could be either plus or minus. Right? Minus the square root of 7 times minus the square root of 7 is 7. Plus square root of 7 times plus the square root of 7 is 7. Now, I'm going to subtract 2 from both sides. Minus 2 plus or minus the square root of 7. Okay, that was kind of an ugly example. But now I have two numbers, negative 2 plus the square root of 7, negative 2 minus the square root of 7. And I can plug either of these in here, they're solutions. They're zeros. This is called completing the square. We're gonna have to practice this a little because it's, again, like I say, it's really valuable, useful tool. It has the feature that you can solve any equation like this. The other methods we've used to factor reverse FOIL using the pattern won't always work. This will always work. I want to go over one more example because I think this is important, and I don't think I really did a very good job here. I think I have a good example in here. Well, I don't have a good example, so let's just do another example. Somebody give me a number between 1 and 5. That won't be that hard.
3.
Someone give me a number between 3 and 5. Someone else.
A 4.
And someone give me a number between 1 and 10. Could be, or it could be negative if you want. Doesn't matter. 7, okay. Well, it's really kind of hard, but we're going to do it anyway. So the first thing you want to do is kind of get this 3 out of here. I hate working with fractions, you're going to hate this example. Okay. So we can forget about the 3. It's not an issue anymore, right? This is equivalent, and it'll have the same roots as this. Step 1, well, so that's step 1. Get rid of any coefficient on the x squared. Step 1. Step 2 is you want to complete the square. Let me show you how you do that. You take this coefficient, we'll call it the b, a squared, ax squared plus bx plus c, the b. You divide it by 2, and you square it. Let's just try this. I want someone to divide this by 2 and square it. What do you get? No? Okay. 4. Okay. Negative 4 divided by 2 is negative 2, squared is 4. Okay. How about 12? Somebody else? Divided by 2, square it. Nobody? I hope you're just being shy. What's 12 divided by 2?
6.
6. And 6 times 6 is?
36.
36. All right. Okay. One more time. How about 4/3? I want to divide that by 2 and square it. 4/3 divided by 2 is 2/3, right? 2/3 squared is 2 times 2 over 3 times 3. Okay. That's the hard part. So here we have 4/3. Oh, is that what I just did? 4/3 divided by 2 is 2/3. We square it, we get 4/9. And we're going to add 4/9 to this side. Now we have our perfect square. We've completed it. So we know that this is x plus 2/3 squared. Again, this is the a squared plus 2ab plus b squared. Could have a minus, and then we have a minus here. Okay, I want to subtract 7/3 from both sides. Let's do that. Oh, I have an ugly fraction. 4/9 minus, how many 9s do I get here? I guess it's 3 times 7 is 21. So I'm going to end up with negative 21 minus 4 is 17 9s. Okay. So this is equal to negative 17 9s. Now we just go through that same process I did the first time. We find the square root of both sides. And now we're going to subtract 2/3 from both sides. So I get x equals negative 2/3 plus or minus the square root of minus 17 over 9. Now, those of you who are paying close attention might want to point out to me, how do you find the square root of a negative number? Well, that's for later. For right now, we would just say this equation has no real roots, has no real solution. This actually is a solution, but we need to be a little further in the course. We need to know about what's called a complex number. All right. What was the purpose of this? You may need to complete the square to do other things. You can always use it. But as I said, it's the hard way to do it. Easy way is the quadratic formula. Who here has seen the quadratic formula before? 1, 2, 3, 4, 5. I'll take that as a yes. 6. Okay, almost everybody or everybody? Does someone want to recite it? This is a good thing. It's ugly as can be, but it's a good thing to be able to just come up with. Someone want to give it a try? I'll start you off. Negative b plus or minus. You want to help me? I guess what I should say is the quadratic formula is the solution to this equation. Ax squared plus bx plus c equals 0. Do you want to try? B plus or minus.
Square root of ax squared plus bx plus c over 2, right?
It's a job to memorize this, right? 4AC over 2A, okay, all right. I'm going to abuse you all in a way. I'm going to show you, because you don't know where this comes from, right? It just works. If you take these numbers and you plug them in, you get 0, right? Or another way of saying it is, this is the same as negative b, well, x minus negative b plus the square root of b squared. I'm going to get tired of writing all this. Now, equals 0. Now, I'm not going to abuse you this way. I could say, go home, multiply these two together using FOIL, and see if you get this. Work really hard, you will. Instead, I'm going to abuse you by completing the square. Don't expect any of you to do this on a test. I'm hoping it will help you remember where we're going with this. So if you remember, the first thing I did was I got rid of this A coefficient. It's gone. It doesn't matter. The next thing I did is I completed the square. Anyone remember how I got that number? Divided by 2 and I squared it. So I divide b over a by 2, that's b over 2a, and I square it. So I get b squared over 4a squared. b squared over 4a squared plus b squared over 4a squared. I add it to both sides to keep things balanced, right? Now I have my perfect square here. X plus b over 2a squared. And I'm going to subtract c over a from both sides. So I get b squared over 4a squared minus c over a. And I want to put this over a common denominator. So I'll multiply the top and the bottom here by 4a. So this becomes 4a squared. This becomes 4ac. So I have b squared minus 4ac over 4a squared. Starting to look familiar. This particular part of the quadratic equation is called the determinant. I guess we'll look at that later. Determines whether you have two solutions, one solution, or no solutions. This has to be greater than or equal to 0 to have a solution. If it's negative, as I said, there are no real solutions. Okay, but back here, so we have x plus b over 2a squared equals b squared minus 4ac over 4a squared. And we find the square root of both sides, but we keep the plus or minus here, because this could be plus or minus, and squaring it, you'll get this number. This is x plus b over 2a. And this is just what we had there before. Although, if you remember your rules of radicals, this is square root of b squared minus 4ac over the square root of 4a squared. Well, what's the square root of 4a squared? 1. What number do I multiply by itself to get 4a squared? It's 2a. Almost there. I subtract this from both sides. And there I really have it. It's just negative b plus or minus square root of b squared minus 4ac over 2a. I get this. I try to solve this by completing the square. So you can see why I could just complete the square if I have some numbers, or I can remember this equation. It's x equals. It's a little complicated, but it saves you a lot of energy if you're willing to commit this to memory. Oh. And again, once you have those numbers, x minus each of those numbers times each other, that's my factoring. That's a lot. I'm going to stop for a second. Take a look at that, think about it. Do you have a question for me about it? You're gonna need to use this, so think about it for a minute. This is not easy. It's like probably the hardest thing we're gonna do this semester. And I hope if you have trouble with it, you're not getting it, please get additional help. Come to my office hours or go to those, I think everybody knows Tuesday and Thursday at 5, in the math office, they have some senior students, junior students, math majors who help people. Let's at least do one problem here. So if I had x cubed plus switch these. No, let's leave it like that. Okay, anyone have any ideas on first thing I might do here to factor this?
Oh, you got rid of the x's. So it would be like x squared plus 4x. Yeah, x plus 4x minus 6.
Everyone see what Dijon did? He just saw there was a factor here he could get rid of. Right? That tells me that one solution is 0, right? All right, good. So now we have this guy here, and we're going to try using the quadratic formula. My A here is 1. This is my B is 4. And my C is minus 6. So I'm just going to plug that in. Negative b is minus 4 plus or minus the square root of b squared, which is 4 times 4, or 16, minus 4 times a times c. Well, you can forget about the a, it's just 1. 4 times 6 is 24, but it's at a minus. So minus 24, which means I can just make it an add all over 2. And we have to do a little work here with radicals. Negative 4 plus or minus 16 plus 24 is square root of 40 over 2. Square root of 40 is the square root of 4 times the square root of 10. And the square root of 4 is 2. So I have minus 4 plus or minus 2 square root of 10. I lost my, oh no, I didn't. And now I can divide by 2, so I get negative 2 plus or minus the square root of 10. So those are my two other solutions of this. So factoring, I get x times x minus negative 2 plus the square root of 10, and x minus negative 2 minus the square root of 10. It's not very pretty, is it? We probably won't get too many radical numbers when we're doing the homework at this point. All right. I think that's I'm going to stop. Again, there's a homework assignment. Do the homework. Come in with questions. You know, focus on this. This is important, and it's kind of mechanical once you get used to it, but it is complicated. It's a thing that most students stumble over. So, that being the case, yep, here we are.